At a pressure of 150 kilopascals and 25 degrees Celsius, a certain gas has a volume of 3.2 liters. What will be the volume of this gas under STP? I am going to highlight STP as a given value, and the reason for that is because STP stands for standard temp and pressure. So standard temperature and pressure are known values that we can find in our reference packet. And so if we look at our reference packet, we're going to see that standard temperature is 0 degrees Celsius or 273 Kelvin. We always want to use Kelvin. And standard pressure is always going to be 1 atmosphere, or in this case, since we're dealing with kilopascals, it's going to be 101.3 kilopascals. So if we were dealing with torr or mmHg, it would have been 760 torr or mmHg. So it just depends on what unit you're using in the problem. So since we're using kilopascals, we're going to use that for our pressure and that for our temperature. So let's fill in the values that we know. We have a pressure of 150 kilopascals and a temperature of 25 degrees Celsius. I'm going to go ahead and convert that to Kelvin. And a volume of 3.2 liters. So those looks like it that all of those are our starting conditions. So I'm going to go ahead and label those as 1. And we want to know what will be the volume of this gas under STP. So our STP is our final values, our values that we are changing to. So that means our T2 is going to be standard temperature. So that's going to be 273 Kelvin. And our P2 is going to be our 101.3 kilopascals. And the question is asking us to solve for the volume. So that's what we're going to be looking for, is the final volume. So since we have pressure, volume, and temperature, that means we're going to need to use the combined gas law, which the formula for that looks like this. P1 V1 over T1 equals P2 V2 over T2. So I'm going to go ahead and plug in all of my numbers right where they belong. So since we have two fractions, we are going to cross multiply and divide. So here's what that is going to look like. You're going to take the 150 times 3.2, and then we're going to multiply it by 273. And that number gives us 131,040. And we're going to set that equal to, and we're going to cross multiply here. So we have 101.3 times x times 298. So I'm going to multiply the two numbers. So 101.3 times 298, that gives me 30,187.4. And I can't do anything with that x yet, so that just stays x. Now if I want to get my x by itself, I need to divide by both sides by the 30,187. That cancels out. And when I type this in my calculator, I get 4.34. And since we're solving for volume, our units are going to be liters.